Hello everyone. Once again, like last time, I'm going to have you work on these first and then you can watch the video and see how you did. I'm going to jump right in. So we have given triangle PQR and triangle LMN with PQ, that segment, congruent to segment LM. Which additional statements is sufficient to always prove the triangles are congruent? So the first thing I would do is draw two triangles that look congruent. So we got PQR. We've got triangle LMN. Make sure that P and L are in the same spot, Q and M are in the same spot, and R and N are in the same spot in the triangles. All right, so they're telling me that PQ is congruent to LM. So I need to know which other information is going to be enough. All right, so what else do they tell me? The first one says that QR is congruent to MN, and the angle R is congruent to angle N. Would this be enough to prove the triangles are congruent? Hopefully you're saying no, because it's angle, side, side, and that's none of the ones that's allowed. So nope, not that guy. Next we have QR is congruent to MN, and angle Q is congruent to angle M. So this gives me side, angle, side. This looks good. You should really check all of them. Notice the next one starts with QR is congruent to MN, but then it picks angle P is congruent to angle L. That's also angle side side, so that's wrong. And then the last one has angle P being congruent to angle M. Well, that doesn't work because P needs to be congruent to L and Q needs to be congruent to M. So this is just wrong in general. So definitely choice 2. All right, 9. Scalene triangle JKL is drawn below. Remember, a scalene triangle means that all the sides and all the angles are different. If median LM is drawn to side KJ, which statement's always true? So a median goes from a vertex to the other side's midpoint. So this is median LM, and it's drawn to side JK. So which statement's true? So the first one is LM is equal to KM. LM is equal to KM. I don't have any reason why that would be true, so I'm thinking that's no. 2. KM is equal to 1/2 of JK. Well, wait a minute, a median makes a midpoint. These are congruent. So yes, that makes a lot of sense. I'll check the other ones. LM is perpendicular to KJ. No, if I had an isosceles triangle or equilateral, that could be true. Someone who thought that would be true might have thought I had an altitude. But I don't, I have a median. So nope, not true for this. And then JLM, this angle, is congruent to JLM. So that would be an angle bisector. And once again, I'm not told that I have an angle bisector, and this isn't isosceles or equilateral, so that does not have to be true either. 12. In triangle ABC below, DE is a mid-segment, and BD is congruent to DE. All right, so a mid-segment means that this is a midpoint and this is a midpoint. So these are congruent and these are congruent. And I'm also told that DB is congruent to, oh, wait a minute here. Let me back up a second. I should mark these as different though, right? So let me back up a second. So D is the midpoint of AB. So that means DB is congruent to AB. And I have that BE would be congruent to EC. But I'm also told that DB is congruent to DE. So I have this right here. So now it wants to know which statement is always true. So now I have to look at all my options and see if I can come up with something. All right, so what else do we know about a midsegment? So a midsegment is always going to be parallel to the third side, and it's also always going to be double. So if this is x, this would be 2x. So if this is congruent to this and this, that makes this side also 2x, and this side's also 2x. So that means it would have to be isosceles because you have two sides that are congruent in this triangle. So definitely not scalene. Let's see, is BD congruent to BE? No, not necessarily. And DA, is that congruent to EC? Same idea. I don't know that, so I can't assume it. So definitely choice 1. All right, 19. In right triangle RST below, altitude SV is drawn to hypotenuse RT. Which statement is always true? So because SV is an altitude, I really have those 3 right triangles here. And typically when we do these, we like to draw them as long leg, short leg, long leg, short leg, long leg, short leg. The problem is they're not asking me to solve anything. They just want to know which statement's always true. So if you try to put the letters in the right spot, I find it to be really, really complicated. So the way I like to do this problem is I like to just keep track and label as I go through the answers. So what do I mean? Let's look at number 1. So it wants me to look at RT over ST. So RT is here, and RT, oh, that's not RT. RT is here, and that means that would be the hypotenuse in the big triangle. And if I'm working in the big triangle, ST would be the long leg. ST in the other triangle, so that would be the medium triangle that I'm now looking at, this would be the hypotenuse. And VT in the medium triangle would be the long leg. So because I have hypotenuse over long leg in 2 different triangles, number 1 looks like the right answer. But let's do one more just to show how something would not work out. So let's look at number 2. I've got VR. So VR would be the short leg in the small triangle. And VT would be the long leg in the medium triangle. VT would still, yeah, this one's like so wrong. So VT once again is the long leg in the medium triangle, and VS would either be the short leg in the medium triangle, or it could be the long leg in the small triangle. But either way, it doesn't make sense. I was switching triangles, so that one's wrong. All right, let's do one more. So we have VR. Okay, so VR is definitely short leg in the small triangle over SV. All right, that's long leg in the small triangle. SV can also be the short leg in the medium triangle. And then RT would be the hypotenuse in the big one. So that one's incorrect. So that's how I like to approach those, is just to go through and make sure I have them labeled correctly. If 2 sides of a triangle have lengths of 2 and 7, the length of the third side could be blank. So easiest way to do this is take those 2 numbers, add them together, and subtract them. So the biggest, but not including, would be 9 that my number can be. And the smallest it could be is 5. So what number falls between 5 and 9? And that would be 8. So the other reason why 8 works is if you take 2 plus 7, 8 is going to be smaller than it. If you do 8 minus 2, that is going to be something smaller than 7. So you just have to make sure that when you add the sides together, they're always going to be bigger than the third side. So 2 plus 8 is obviously going to be bigger than 7, and 2 plus 7 will be bigger than 8. So we know we're good.